Hi, good afternoon. Welcome, everyone. We will begin the webinar shortly. My name's Eric with Bobcat Cam, and we will be starting at 1 o'clock Eastern Time, so in just a couple minutes. We'll wait to make sure we have anybody else joining us for the Lathe webinar this afternoon. In the meantime, if you could go to the comments section here in the webinar, you can see the Bobcat Cam technical support phone number. That's 727-489-0003. And right below that is our email address for tech support, and that is support@bobcat.com. So if you have any issues with the software program, you can email us a part file, or maybe email us a sample program of anything you have any issues with in the software program, and let us know about that. And you can also call us to create a ticket as well with our tech support team. I know we've got the preview here of milling. That was one of our previous webinars last month on 3-axis milling. Advanced roughing features there. And you can always go back to any of these webinars on this page to be able to view previously recorded webinars here. I'm just checking here with our Vimeo program and with my audio here. Please let me know in the comments section if you guys can hear me. Make sure the audio and the video is working properly. If you're able to see the preview screen and able to hear me through the audio, please let me know there in the comments section, and we'll get started here in just a couple minutes. Thank you, everyone, for patiently waiting. I'm going to wait maybe one more minute just to see if there are any other stragglers that will be joining us here with the webinar, and we'll be viewing our webinar here for 2-axis lathe functionality in the software program. Please let me know in the comments section that you all are able to hear me through the audio there, and also be able to see my screen. I currently have just the loading page up for our webinars. And we'll get started here in the next few minutes, in maybe 30 seconds here. Okay, I think it's about time. It's 2 after, so we will get started here with the webinar. Hi, everybody. My name's Eric. I am the demo technician with Bobcat Cam. I am normally doing demonstrations of the software program for potential customers, showing them everything we have in the software program, everything and anything pertaining to them, whether it be lathe like we're going over today, milling, 3, 4, 5-axis milling, laser plasma water jet machining, and also wire EDM machining. We also offer mill turn. That would be a lathe with live tooling. We're not going to be going over that today. We're just doing basic lathe functionality. So if you all are interested in looking at mill turn functionality in the future, please let us know in the survey we'll be sending you later so that we know exactly what you all want to see in these webinars here. But today we'll be going through the basic cam functionality for lathe 2-axis here. As you can see here on my screen, I'm in the backplot feature here of Bobcat to be able to see the tool, follow along the tool path of any of our turning operations here. And we'll be going through some of the functionality that we'll be seeing here, whether we're programming from a 3D model like I have here on the screen, whether I'm programming from wireframe or pretty much anything else. I guess the other option would be maybe an STL file or something like that. We'll start by programming with a solid model here, and then we can draw our own model and see some of the other lathe functionality other than turning the OD here and then doing a groove operation here in this groove. So to begin with the CAD functionality here, you can see I have a solid model. In Bobcat, we use wireframe for geometry. So if we only have a 3D model that we've imported, or maybe we've gotten rid of the wireframe after we've created the solid model, we can go back to wireframe with a very easy CAD function. So you can see here, right above me here in the screen capture, sort of in the bottom right-hand corner, you can see the layers page, and that is where we have our CAD layer, our solid layer that I could turn on or turn off. Right now I've got wireframe, so I can go into my select mode. And for the purpose of this demonstration here, I can delete the wireframe by hitting delete on my keyboard. I can show the solid again, and maybe if I want the wireframe on a different layer, I can go to my layers page. I can right click in this window, go to add new layer. I'll name it wireframe here. And I have it active with a green check mark. Now to create the wireframe, I can go over to create 2D. And so I'm sure many will be familiar with the extract edges. That would be for a solid model on the edges of the surfaces there. Now we don't want the edges of the surfaces, we want the OD here, the profile of the OD. You can see there's sort of a line there, but it's not going to create that for us with the extract edges function. The extract edges function, just to show you, is if I selected this front face here and click OK, I can hide the layer that the solid is on and see that wireframe that I created, just the surface edges of the front face. I'll undo that extract edges function, and then I'll go to what we would use to create the profile of any OD or ID of a part. By going next to that extract edges, we have spun profile. So if I select this spun profile CAD function, I can either select the solid model or sort of window select over the surfaces and click OK. It always starts off with along the x-axis, which is the axis we want if we're going to be creating the profile from a top view. So if I cancel out of the spun profile, I hide the layer that the solid is on, we have our wireframe that we can begin our turning functionality with. Looks like it's a little hard to see the wireframe. I'll zoom in a little bit to sort of see it there. And so I'll zoom out a little bit, and we can begin our turning job here by going to the top, going to Cam, and starting a new job. We will select turning for a lathe. Again, we also have mill turn for a lathe with live tooling. So we're going to be looking at turning, and we will be selecting our machine. Now, by default, when you install Bobcat, it will have the BC2X lathe as your machine. That stands for Bobcat 2-axis lathe. It's just a generic machine that we have built into the software program with the post processor selected as the Bobcat 2-axis lathe, which is a generic FNUC output of G-code there. So if we scroll down, I'm going to go to the Haas 2-axis lathe just as an example to see the formatting for a Haas machine. We can go down to the bottom and go to the stock wizard. We can define our workpiece. So if we have the solid model, which I do, I'm going to show that layer for now and select the workpiece here. That way we can view the workpiece in simulation and see exactly how much material is remaining with our turning operations we programmed with the workpiece here. So how much stock is still remaining versus the workpiece. Then our next page here is our stock. This is where we're defining our stock diameter. Video frozen. Let me zoom in and zoom out. It says video frozen. Are you guys able to see me zoom in and zoom out here? Looks okay on my end. Let me know if you guys, if the video is frozen for you. But yeah, so with this stock on the left side here on this page for stock definition, we can define our stock by setting the stock diameter. So the outer diameter of the stock, I can type this in by typing in, I think it's somewhere around 4 inches for the outer diameter of the stock. For the internal diameter, if there was a hole already drilled through, I could start, maybe I can type in a 1/4 inch here and you can see the stock updated with a 1/4 inch hole for the stock there. Type that to 0 again. And then I can type in the length of the stock. I think that is also at 4 inches as well. And we can see it update there. Let me know if it's not updating on your side there, Steve. Let me know in the comments section. Thanks for letting me know. You can hear the audio, but if the video is frozen for you, please let me know there if it's still frozen. Yeah, so we've got our OD of the stock at 4 inches. We've got the length of the stock at 4 inches, and then I can click OK from here. Then we can go to our turning operations, and that is found here at the machine setup at the bottom of the turning job in our cam tree. Sort of a side note with the cam tree and with any of these other pages on the left or right hand side, like our layers manager, our cam tree, if one is not showing, maybe I've X'd out one of them, maybe I've X'd out the layers page, I don't want to see it either accidentally or on purpose. If I want a larger CAD workspace there, I can X all of these out. And if I want to bring them back, I can right click at the top and go to any of these managers, we call them. We can open the layers manager again. And then when I right click, it will have a green check mark saying that it is open. If it's open and you don't see it on either side, it could be hiding behind the screen. If it is sort of separated from the software program, that way you could put this on a second monitor. Maybe it's hiding on a different monitor there. If I want to bring it back, dock it into the software program again, I can drag it over, and you can see that arrow that shows on the right hand side there. I can hover over and then dock it to the the CAD workspace here in Bobcat itself. So from here, we can go into our turning operations. I have the turning job here already programmed. Just for the sake of going through the turning operations again, I'm going to highlight it by left clicking on the turning job above the one I'm working on, and then I can hit delete on my keyboard to delete that turning job. We'll start from scratch. We're doing it live here. Okay, so we've got our stock, we've got our machine set up, and that's set up at the front face of the stock. Maybe for whatever reason, if you have your machine setup or your work offset anywhere else located at the machine, you can move the part and the wireframe out a little bit more. Maybe if you're touching off your tools at the the front of the chuck rather than the front of the stock here, and you can move it forward. So for here, we can right click on machine setup 1. We can go to our different turning operations. So we have lathe end face, that is a facing operation, then a turning operation, either on the OD or on the ID, groove, drilling, tapping, threading, a cutoff operation, and also stock handling for a bar feeder. So we can select lathe turning, select geometry. So again, I don't know if it selects, I'm just going to test it out. Yeah, so even if I select the geometry for the surface, it doesn't produce any toolpath for us when we compute. So when I right click on machine setup 1, go to lathe turning, and then select my geometry. I don't want to select the surfaces, I want to select the wireframe. So I'm going to hide the layer that the solid is on here. And then I'm going to select these entities here. You can see that it chain selects everything once I left click on something. That's a newer feature here called the picking manager. So if you can see all the way on the left hand side of my screen, you have this tab that is hidden called picking manager. I'm going to hover over it to open that up, and we have this auto connection option. It can be really helpful for chain selecting wireframe like this. I don't want to shift and click on something or shift and click specific chains. It can be really helpful for that. It can also be really helpful for chain selecting surface edges is the main reason for that picking manager. So if you go into the help topics for the picking manager, it's a great feature to use to chain select not only wireframe here that we're seeing, but surface edges also can be really helpful. So I will clear all of that selection because I only want the OD. So I'm going to start here by just clicking on this first line, and then I'm going to go out to the end here, hold shift, and click on this last line, this chamfer here. I want to do all the turning on the OD there. So then I click OK. Go to my next page. It starts off with turning on the OD. I could also select turning on the ID here, for example. And we also have front face. So rather than, you can see the toolpath here, rather than the OD going horizontally, front face would go vertically. So more of a facing operation. And then also back face with a facing operation on the back side of the part. So I'll select OD again. I can select from stock. I'm selecting from my original stock that we have. We could also do it from geometry if there was area here already turned down, and also a custom amount if we've started off at a certain turning operation beforehand and turned down the extra amount to avoid any air cutting there. So I'll select from stock. We have extensions, so I could start a certain distance, sort of like a lead in and a lead out tangent to the cut there. And then our next page, it starts off with a roughing operation here in the current operations list. In the available operations, we have a roughing operation, a basic finish pass, and pattern repeat for multiple spring passes. Now I can highlight basic finish and move it over with this arrow here to add that operation into our current operations list. I can sort each operation by moving it up or moving it down here in the list. And I can also delete any operations here that I don't need. I normally don't go through the process of selecting a finish pass, moving it over. I usually go to our default strategies up at the top. That's what I usually do, sort of a workflow with turning, also with milling and all of our other programming options, because we have some machining strategies here. The roughing just has a roughing as our current operations. The default strategy for rough and finish has just that, a rough and basic finish pass. Pattern repeat, and the basic finish pass. I normally select rough and finish so that we've got a roughing and a basic finish pass there in our current operations list. Then I go to the next page. Under posting, we have the option to post out in separate moves or in can cycles. So I'm going to select can cycles so we can see the can cycles for the roughing and the finish pass here. We can define the tool and the tool insert. I normally check this box, show tool holder, to see the tool holder geometry and to see that it's the right orientation of the tool here. We can now put in RPM or constant surface speed down here. And then up at the top, I can click on Tool Crib to open the Tool Crib and the Tool Library page. I can select any of these tools here. I normally sort by either tool insert type. If I'm looking for a diamond-shaped tool, I can select the V tool category, C tool category. I can sort it by tool nose radius if I'm looking for what tool nose radius I'm looking for there. I can also sort it by tool number here. And if I want to use a different tool, I can just click on one of them here. And you could add the tool from the library to the tool crib that way. I normally drag and drop it from the tool library up to the top to the tool crib. Just that I am remembering I'm bringing it to the tool crib and adding it here to the tool page here. And then from here, setting my feed rate and all of those great options there. My next page, I am turning on collision detection here, down at the bottom. I can select system compensation on with collision detection. And that way you can see this preview here. If there's any non-cutting part of the tool will avoid that area to avoid any collisions with the tool into the stock. And then I can also use tool holder, make sure the tool holder doesn't have a collision there. Our machine compensation option here also offers G41 and G42 output. Then our next page, we have options for a depth of cut for each pass. A finish allowance, so we can leave a certain amount of material on the floors and the sidewalls for the finish pass to clean up. Then we have rapids where the tool will rapid from and will rapid back after the operation there. Our next page is for lead in and lead out options. So we can start parallel to the cut, start at a perpendicular distance here that I set, horizontal, vertical, at an angle, or a custom distance in Z and X. I want a certain custom angle there. Start at parallel and vertical up. And we'll go to our next page. Advanced feed rates. We can convert rapid moves to feed moves, and the purpose of that would be if we are not able to set a rapid rate at the controller, we can convert rapid moves to feed moves. So essentially we could set a rapid rate in the G-code. We can also set a feed rate specifically for our lead in and our lead out. And our last page here for the roughing operation, you can see on the left-hand side, they're each highlighted every time I go to the next page. I can also skip around by clicking on them here on the left side. I'll click on MDI, that stands for manual data input. It's a newer option here. If we wanted to add any various G or M codes before or after an operation, if I wanted to add a dwell time, set a different spindle speed, set a create any raw text before or after an operation. I can click on raw text, I can click on after operation, and add that command in. You can see it creates a text box down here at the bottom. You can enter anything you want here. Raw text will create it just as what I have here typed in. With the option for comment, it will automatically add parentheses, an open parentheses at the beginning and the closed parentheses at the end here. Then our next page is going right into the finish operation. You can see it says rough here. The only reason for that is because this tool is coming from the rough category in the tool crib. So if I go to the tool crib, I can see that we're in the rough category. If I want to go to the finish category, because I've got some finish tools in here I want to select, I'll sort by tool insert type, and maybe I'll use one of these VNMG tools here to fit into the groove a little bit better and fit on the chamfer on the back side of the part a little bit better. I'll click and hold, and I'll drag and drop it into the tool crib here. Then I can click OK. And then you can see that it says finish on the left-hand side, because that way it's telling you it's in the finish category of the tool crib there. Then we have our feed rate that we're setting. Go to our next page. We can do a continuous finish pass. I've never seen a reason for this, but we do have an alternate option. Let me know if you guys use this at all. The alternate option will go horizontal. It'll go to the left horizontally, and when we're doing a vertical cut, it will come down on the vertical walls there. We could face the vertical walls only, or turn the diameter only of the part. Let me know if you guys use these options at all, because I've never seen a real necessity for it. Usually customers will use just a basic continuous finish pass here. And then I'll turn on collision detection, use tool holder, go to the next page. Finish allowance will be 0 because this is our finish pass. We're not leaving any material left over there. Then the same options as our roughing, where we have our rapids, our leads, our advanced feed rates, and our MDI page. And so I will click compute. We'll see some toolpath here from the wireframe. We could also show the solid as well to see that and just sort of see the difference, see the extra material remaining from the roughing, but from the finish, it's going to finish everything on that side, but it's not going to finish everything here in the corner inside of the groove. So we'll want to do a grooving operation next. To do that, I can right-click on Machine Setup 1, go to Lathe, Groove, select Geometry, hide the solid from my layers, and then select my geometry here. I'm just going to select, just sort of window select these 3 lines here, and click OK. Next page, we're turning on the outer diameter again here. Our next page starts with a roughing. If I want to do a rough and finish, I normally go to the default strategy here for groove rough finish. Adds that in for me. Saves me a click so I don't have to go to my available operations for my groove finish and add that in. So then our next page, maybe we could do can cycles for this one as well. We can define the tool here for the groove operation. Next page, we can do a standard cut pattern, just sort of stepping over the whole time, or a single pass option here. Our next page, setting up the step over, setting 10th thou left over for the finish pass to clean up, setting our rapids, our leads, our advanced feed rates, and our MDI page, just as we have in all of our other turning operations here. Then we have our tool for the finish pass, going to be the same one as before. Turn on collision detection. And we have an overlap option. So this force down cutting option will force the tool down any straight walls and come back on the back side of the groove there and overlap if we want to here, or just a basic finish pass here. Then our next page, zero allowance for the finish pass, our rapids, leads, advanced feed rates, and MDI page. So I'll hit compute. We'll see the toolpath right here. I think we got some toolpath. I can't really tell with the other toolpath for the turning of the OD. I can right click on that feature and go down to blank unblank toolpath. We also have that icon on the left hand side to show or hide the toolpath at any time. I don't see any toolpath. It's also hard to see with the stock, so I'll blank the stock as well. And yeah, I don't see anything yet. I see geometry, but I think it thinks it's already cut to size. So with that turning operation, I'm going to avoid that groove by going back into the feature. And I think we have a couple options here: remove primary undercut and remove secondary undercut. So remove primary undercut will remove any undercut like this, the groove here. So it's going to avoid that whole area there. And the groove should be able to come back. If I update geometry and compute toolpath, if it's not showing any toolpath after that, usually what that is that the tool is not able to fit into the groove here. So I can make sure of that by going to the top, going to evaluate, going to measure one. I'm going to measure the width of this, or the distance of this line. So it's the width of the groove here where the total length is 123. I can go back to the cam tree, double click on the operation here of the tool page here. Our tool width is 125. So it's too large to fit into the groove. So I'll have to go to the tool crib and use a smaller tool. I'm going to sort by tool width here for the groove tool category. None of them are smaller than 125. So I'll just go to the tool crib and modify this one by double clicking on it. And tool width, I'll just make it 100,000. Click OK. Tool width for this one is 100,000. Let's go to the next one and make sure that one is the same tool. Looks good. Hit compute, and I think the collision detection is not liking the tool holder. I've gotten that one before. So I'll turn off use tool holder. I think that works for us. Cool. So we'll see the back plot here. The tool will come down, go along the sides here. If I zoom in, we can see that a little better. So it comes down on this side of the wall, moves over, comes back up, moves over, comes down on the back side of the wall, and then goes back to the middle there. So that is our groove operation there. And then we'll be able to look at it in our simulation. We'll go to the top and hit Start Simulation. I can view simulation from the front side of the stock here very easily by clicking on this front surface here. Over on the bottom left, this gnomon here. I can also move it around here. I can look at it at an isometric view by clicking on one of those corners. But yeah, very easy to be able to view exactly from the front side by clicking on front here. And then we'll look at simulation. Change the run speed for simulation here. Type the toolpath, and I'd be able to see the estimated cycle time based on the feed rate I have set up here. While that's running there, Leon, thanks for the question. Quick question: how do I change the retract on my groove step over? After we view simulation here, Leon, we'll take a look at the groove operation again and see if there's a retract setting there. That's a good question, though. can speed up the simulation process here at the top. If you don't see your cycle time at the top right here in your simulation, you can change it up at the top left here. So rather than time mode, you can drop that down. You have length mode, which it'll give you distance traveled. NC mode, which will give you how many lines of code, about 202 lines of code there. And time mode. So we can see the finished part here. And we'll go back in. We'll close out of simulation and we'll go back to the grooving operation here. So let's see, is there a retract option? Rapids, leads, advanced feed rates. Maybe in the roughing, let's check the roughing here. I know that we have multiple depths. We have a pecking option here. We have a peck retract. Looking for any other retract options here though. Let's see. Depth cut maybe. That's depth. The only one I see currently, Leon, is the peck retract option. So you can see it retracting just the certain distance there. Just sort of thinking about it on the fly, you could set the peck distance to the total depth of the groove here if you don't want to use a pecking cycle, but then you'd be able to manipulate the retract here by each peck. It's going to go to a certain clearance plane. That's what I'm thinking at the moment. The only other option I can think of for your retract options would be if we go to, we'll go back to the stock page here. So if I right click on stock, if I right click on stock, go to the stock wizard, then our next page is our machine setup, and we have clearance planes for this here. So that might be it, where you can set the, your face clearance plane, your outer diameter clearance plane, and internal diameter clearance plane. So I think that's what you're looking for, is the first diameter option, so that it won't go 1 inch above the stock. You could have a clearance plane even higher for your retract options there. Let me know if that works for you, or if you have any other questions, please let me know there. Thanks for the question, Leon, and yeah, let me know if you have anything else there. Other than that, I'll hide that, and let's see. I think, well, once the simulation looks good, we can close out of simulation, and then we can hit post up at the top. It'll generate the G-code here on the right-hand side, and we can scroll through it. I'm going to look for the can cycles here. Here is our can cycle for the roughing operation. I'm going to enlarge the text here a bit more. I can hit Control and use the scroll wheel to view the text a little bit larger here and see exactly what I'm looking for. And then we have our G71 cycle. P11 and Q46 is where we're starting and ending this can cycle here. That gives us our geometry for the roughing operation, and then we get to our G72 can cycle somewhere around here. But yeah, that's how we're able to view the G code. Let's make it a little smaller here, and then be able to make sure everything looks good in the G code here. This is formatted for a Haas 2-axis lathe. So if everything looks good, we can right click here in the posting window, go to save as, and then we can save this onto our desktop, save it onto a flash drive or a network drive, and be able to load it onto the controller from there. One other option we can look at here before we get into some of the CAD geometry for Lathe, we can right-click here. Rather than saving the NC file, we can bring the NC G-code into the NC editor. It'll open up a new window with our NC editor here, where we can edit the G-code here. And then we can go to the top and go to Tools and go to Start DNC Transfer. We can set the port number, the baud rate, and all of those settings if we're using an RS-232 cable from the computer to the machine. We can send or receive G-code from a cable here by setting all of these settings that the machine has set up in the controller. And we can also tab over to character delay and line delay. The character delay, where we can set a certain number of milliseconds to wait to send each character of the G-code. I know customers usually use this line delay, so we can wait a number of milliseconds for each line of G-code to be sent to the machine from an RS-232 cable. These are our drip feed options. So if you're using an older machine, can't take a whole lot of memory, you can set drip feeding. You can set the port number, baud rate, and all of those settings to send or receive from the machine with an RS-232 cable. So we'll close out of this window. We'll close out of the window for the NC editor, get back to BobCAD, and that's about it with the programming for CAM inside of Lathe. We'll also go through creating CAD geometry from scratch if I haven't imported a solid model like this, and see how to draw the lathe part and program it as well. Before I get started on a new part file, let me know if you guys have any questions in the comments section before we get started on that. And if I start going ahead of you, if you guys have any questions and might get caught up in the programming side of things, I will answer any comments, questions, concerns, anything like that at the end of the webinar here as well. So yeah, we can go to a new file here, go to the top, go to New, and we can begin designing the turned part. I'm going to zoom out a little with my scroll wheel. I'm going to go to the top, go to Create 2D. Actually, before I go into my sketching options here under Create 2D, I'm going to go to the left and go to Home again and go to Turning Mode, which is this last option on the right here. Before I click on it, you can see that we're sketching in X and Y coordinates. So just a basic graph where we are drawing in X and Y coordinates. If we're more familiar with the turning coordinates in Z and X coordinates, I can go to turning mode, and you'll see that Z is now replaced there and X is now replaced there. So now we're sketching in Z and X coordinates if we're more familiar with the turning coordinates on the lathe there. So with our turning coordinates there, we can go to the top, go to Create 2D, go to some basic points and lines and arc functions here to be able to sketch our turned part. I normally just start by going to Line and sketching some lines here. I can start from the CAD origin here, go up in X to tell the software what our OD is. Let's say, now if I'm going up 1 inch, that's going to be the radius. So if I go up 1, 2, 3 inches, our OD is going to be 6 inches from here. I'm going to click and then move my cursor over, let's say 1, 2, 3 inches over. Now, if I don't have it exactly right on the 3-inch mark, I can go over to the left side and make sure that it is 3 inches. If it's not, I can change the length here to 3 inches and click OK. Then maybe we'll do a tapering here. If I can sketch from that line and go out, go down. Let's go up 2 inches here. Not 2 inches, but let's go up from that point. Maybe let's go up 1 inch. We'll go over to the left-hand side. Incrementally, I'm going -1 inch in Z. And let's say I'm going up 1 inch in X. Should give me an angle of 45 degrees if I'm going over 1 and up 1. And click OK. You can see the angle is at 135. So that's 180 minus 135 gives us that 45 degree angle there. Hit cancel. And then I'll go out a little further. Go to line function again from this endpoint. I'm going to click on it. You can see if you're familiar with the older versions of Bobcat, you used to have to go to line join to join a line there. You used to have to go to line tangent and all of those fun line angle. We have some of those that could be useful, but in this line sketch function, everything's in here now. You have your continuous. You can continuously sketch a line. You can start from an endpoint. You can start from a tangency point of an arc. So the sketching functions are a lot easier than our older versions of Bobcat, if you're familiar with those versions. Let's go over 2 inches. And maybe we'll just focus on that. We'll have we'll make these a couple of arcs here, and then I can make the solid model here by first closing things off. So if we're looking at the turned part here, I'll go to line. From the endpoint here, we'll go down to our z-axis, z0 there, and click there. And from this area here, I'll click and go down to z0 and click OK. Then I'll click cancel. And we can create the 3D model very easily by going to the top, going to create 3D, and go to revolve. That's how we create revolve surfaces to create a 3D model. And I can hold shift and click to chain select that whole chain there. I'm going to click and hold my scroll wheel and revolve over. That's just half of a part there, and I can make the other half by changing the rotation angle from 180 to 360. And then I can click OK. And there we have our revolved part that we created. Cancel. Look at it from a top view again. And if I want some arcs here, maybe I can go back to the wireframe and make some arcs for a radius in the corners there. Get rid of the solid model by just hitting undo at the top. Go back to our wireframe here. This is what I usually use for all of our turning operations because we don't need any solid models or any surfaces to program from. We need wireframe to program from in the turning there. So I go to create 2D, go to arc, and instead of sketching a circle, we could create a fillet, I suppose, in the arc functions, but we do have a fillet and a chamfer option here. So maybe let's start with a chamfer on this corner. I just have to type in the angle amount and type in the distance of the chamfer I want. And I just click on one line and click on the second line for that. Let's see, did it create anything? Might be too large. 45 degrees, 1/4 inch. Should be okay, but let's type in something different here. Click on one line and click on the second. Chamfer. 45. Yeah, I think I have to make a smaller one because it's not liking that. Wants a smaller chamfer because this area is too small. And then after, we'll go into fillet because that's really what I was wanting to focus on. We'll type in the radius here, and then just like in the chamfer, we click on one line, and then we click on a second line to create that radius there of 1/4 inch. And maybe here in this corner, I'll change it to a radius of 1/2 inch. And again, click on one line and click on the second one to create that radius there. Here we go. Again, if I want to create the 3D model, again, go to Create 3D, go to Revolve, and chain select everything I've made there. But we just need the wireframe, so I'm going to stick with this here. We can also create the 3D model separately to the wireframe, just to show you that. We can go to our layers page here, and just like before, we can right-click, add a new layer, maybe name it solid. We can go to Create 3D, go to Revolve, chain select everything. And then we can have that 3D model here. We can have that 3D model under the solid model. I'm going to make the CAD layer active so that I'm going to the wireframe and blanking out that solid. So that way I can show or hide the solid at any time that I want to there. So back to our wireframe, we can begin turning down the outer diameter of the stock. Oh, I was also going to show turning on the ID. So let's undo the solid model there. We'll go to Create 2D. We'll go to Line. And I normally will sketch any geometry of the ID or any holes with dashed lines. And you can do that by going down to the bottom right of your screen here, which I'm on. Move that over. There we go. You can see down here at the bottom, you have this solid line option or sketching with a dashed line. That's what I normally do. And you can see it's normally going to the midpoint or the endpoints of the line in the sketch functions. Over here on the left-hand side, I can uncheck the box join to closest snap point. So now I can go up just an inch here with the radius and move over, let's say 3 inches. The length here, I want to type in 3 inches exactly. I want that to be x1. Okay, cool. Then I can click OK. Sketch the OD there. If I don't want this area, this solid line down at the bottom, I can go to Utilities, Quick Trim, and trim away to the next intersection there. So now we've got that opening for the ID. And maybe if I want to add that extra line here, I could always sketch that line going down, or make the tapering if there's a taper for the drill there. But that looks good. We'll begin our turning operations here, our turning job. Again, by going to the top, going to Cam, and starting a new job. We can define it as a turning job. And we'll select Fanuc for this one. We've got a Fanuc OIT machine and controller selection here. And then go to the stock wizard, define our workpiece. So again, if I have the solid model, I can define it here. I don't have that, so I can skip that page if I want to here. If we don't need to see it in simulation, go to the next page. We have our stock diameter. I think the total diameter was 6 inches. Oh, it was 6 inches, and then I went out a little further. It's actually 8 inches. And then our length is 2, 3, 4, 5, 6 inches for the length there. And then I'll click OK. So we're going to do an OD operation for this area right here at the top. And then we're going to do a drilling and boring operation for the ID here. Good question, Ray. Is it Fanuc or is it Fanic? I'll let people decide in the comments section which one is it. That is a good question. From what I've heard, it depends on where you're located. In some parts of the country, it's Fanuc, and then for some people, they just call it Fanuc. Let me know how you pronounce it there, Ray. How is it pronounced there? We'll go to the cam tree. We'll right click on machine setup 1. We'll go to lathe turning and turn down the outer diameter. Go to select geometry and start from here and work my way all the way back to the backside of the part there. So again, by selecting it, I'm going to just click on the first one, and then I can hold shift and chain select at the end there. And then I can click OK. I can go to the next page. Ray, thanks for letting me know about the audio. You may have been clipping there. Turned it down a little bit. Let me know if that's any better for the audio there, if it's not being clipped. All right, and so we're turning down the outer diameter of the stock from the stock area there, doing a rough and a finish pass. Our next page is in separate moves or can cycles. Defining our tool again. Turning on collision detection. Now down here at the bottom under this parameters page for our turning operations, a couple great options. One is our trim to stock option over on the right hand side, where if there was areas already turned down from a previous turning operation, you can avoid any of those areas. So if it's not a perfect cylinder, if it was already turned down in a certain area here, you would just check this box trim to stock. Bobcat would understand and calculate the tool path based on that geometry that you have for your stock there. And so you can see if it's not trimmed to stock and we have this geometry already turned down, we'd be doing a lot of air cutting. A trim to stock option would be able to trim all of the tool path away to our stock that we're starting with for this operation. The other option down on the bottom left is our chip break option. This is a newer option where we can set the length of cut here. So for example, I'm going to type in every half an inch. The roughing operation here is going to, we'll see it better in the back plot. I can explain it. If I expand the feature and I right click on rough and go to back plot, we can see the tool moving across, and every half inch is going to retract just a tiny amount so that it will leave, if there's any material built up with the tool, it will remove that material with that retract at every half inch. So that chip break option is pretty neat, newer option there. Let me know if you guys have used either of these options, the chip break or the trim to stock option, to save time with air cutting there. Then just as before, our rapids, leads, advanced feed rates, and MDI. Set up our finish tool, turn on collision detection, and then the same options as before for rapids, leads, advanced feed rates, and MDI. I'll hit compute. And then I'll zoom out here, see the toolpath there in green, and we'll get into turning on the ID. By right-clicking on Machine Setup 1 in the cam tree, first I'll do the drilling operation by going to Lathe Hole, select Geometry, and I'm just selecting a point for my total depth here. The ID here is 2 inches, so for the diameter, maybe we'll get down to, using a 7/8 tool to start with here. And I'll type in 7 divided by 8. Not great at those decimals there. So we're at 875. And also, a side note, we can do basic calculator functions in here: add, subtract, multiply, divide. So I can do 7 divided by 8 and give us that 7/8 diameter. Then our next page, we're doing a center drill and a drill. Set up the geometry for the center drill and the feed rate here. Set up the depth. And for all of our drilling operations, we have pecking options for even the center drill now, drilling operations, everything in here. You can peck or fast peck down into the material. As we get into peck turning, Ray, does the chip break option create a peck turning type toolpath? No, I don't think so necessarily. It only goes at a linear move. It doesn't actually peck down into it. If I turn it back on here, we'll even see it in simulation. We only have the length of cut option, a time interval where it'll retract after a certain amount of time, or how long the length of chip we can set here. But then we don't have really a pecking option. As it goes down, it's just going to do the linear move there. Is there a peck turning option where it goes down? Trying to find out your question here, because if we move across here, then it just goes linear across. Is there an option in other programs where it will vertically go down first and then move over? Is there a slice versus a pass option in other CAM software programs, or is there a different option that you're referring to? Let me know there. We've got our center drill. We've got our drill at 875. We can do a pecking operation for the drill here and set the peck depth there, and then hit compute. Got the drilling operation there. We can see right here, this red line is where that drill will leave off. And I'll backplot it here. So it's pecking at 475 depth for each peck distance there. And that's how much material is remaining for the turning operation on the ID. You can right click on machine setup 1, go to lathe turning, select my geometry as these two lines here, the two dashed lines for my ID. Next, we are turning on the ID. Next page, we're doing a rough and a finish pass. Look at output in can cycles again here. We can define our tool, make sure the geometry looks good. Now the width of the tool is huge, so before our webinar, I went in and sort of defined a demo tool here. If we look at it, we can change the geometry of the tool holder here by going to Edit Tool Holder and changing the geometry here with all the parameters here. You can also create this as a drawing and pick a custom geometry as well. At the end after we're done with this, we'll look at creating custom geometry for a tool insert also. So we'll go in, define that tool. Oh, make sure we've got the right mounting orientation here, down towards the bottom of the tool crib. There we go. That looks good. Should be small enough to fit in there. I'm going to use the same tool over in the finish category and hit compute. I think we can use the, let's see. I think we can use the trim to stock option there, as I mentioned. Where's that from geometry? There we go. that works. So we have our tool path for the roughing and turning on the OD. Look at the chip break option. We have our drilling operation, center drill and drill, and then the rough and finish for the lathe turning. We're starting right where we left off from the drilling operation based on the trim to stock option there. We'll take a look at the simulation. View it from the front here and hit go. So you can see the retract every ½ inch so that there's no material buildup at any of those while it goes all the way across the stock there on the OD. And then we've got the drilling operation and then the turning on the ID there. You can see the stock as transparent so that we can see that taper of the geometry of the tool there. Now we could shorten up the distance of the drilling operation if we needed this to be straight walls so that there's not a tapering there. It's a great way to see the transparent stock there to see our exact geometry of the part there. So once we're done, we can close out of simulation. We can go to the top, go to post, and generate the G-code here on the right-hand side. Right-click, save it, and put it onto a flash drive from there. One last thing that we can look at is creating a custom tool, and that is by going to a new file, going to create 2D, and I'm going to create just a basic rectangle shape just for the sake of time here. Type in the length and width of the tool insert shape. I'm going to draw it right down here in the first quadrant here of drawing here. I'm going to create the radius by going to fillet. Type in the radius here, let's say 1/64. Click on the first line, click on the second one there. So we've got our radius. I'm going to go to point and create a point at the CAD origin for our theoretical tooltip. And then we have that should all be good. So once we've got the tool insert and the theoretical tooltip, we can go to the top and go to CAM and go to the tool library. This is a tool library for all of the specific tool categories for drilling, for mill, then for lathe. I'm going to drop that down. I'm going to go to rough, add a new tool here in the tool library for roughing and double click on it. I'll name it custom shape tool. And go down to the bottom, select custom shape here and assign tool insert. I can define the insert shape. I can go down and click on the reference point, and that should be it. Yep. So there you can see the tool insert. If I wanted that, like the other tools here, the reference or match circle here in the center, you can also define that by creating a circle here in the center of the tool. But that also has to be a dashed line geometry, or construction geometry, you could call it. So down at the bottom right, I'm going to go to dash lines. I'm going to go to create 2D, go to arc, make a small diameter here of an 1/8 inch. And go right to the center of the square there. Now I can go back to CAM, go to tool library, go to the lathe category, go to rough, add a tool, click on it to customize it, name it here, and then go to custom shape and assign tool insert. So here's our insert shape. Our match circle is going to be this circle here, and then our reference point is going to be down at the bottom here that I defined. Then I can click OK, and there is that tool that I created. So that's how you create a custom shape for the tool. Very similarly, you can just create the drawing of the tool insert down at the bottom, then go to Edit Tool Holder and pick the custom geometry for your tool holder there as well. It's just got to be some sort of rectangular shape like this, or however it looks on your machine there. get the specific dimensions and type it out and create the custom shape for your tool insert and your tool holder in the turning category. Now that's all I can think of with the turning features here. When it comes to creating a turning job in BobCAD, did some turning on the outer diameter with this part file, and then we went over, created a custom shape for our turned part here, created it in the CAD geometry in BobCAD, and then programmed it with creating an OD turning operation. So we created a turning operation on the outer diameter, created a center drill and drill operation in the center, and then a turning operation on the ID. I'll stay for a couple more minutes to see if anyone has any questions. But yeah, that's the end of the webinar today. We saw CAD and CAM for Lathe and also creating the CAD geometry for a tool as well for your turning tools. And this will be recorded so you can reference it again at any other time there. Our next webinar will be not next Wednesday, but the Wednesday after. So that will be June 5th. And yeah, if we will be sending a survey to any customers that registered so that we can know exactly which webinar you would like to see next time. We want to make sure that these webinars are tailored to exactly what you would like to see next time. And yeah, please let us know what you would like to see so that we can have it exact to specifications, what you guys would like to see there. So thank you everyone for viewing the webinar today. And thank you, Ray, for engaging in the comment section. Thank you everyone else for viewing in here in the webinar today, and have a great rest of your day. We'll see you next time. June 5th will be the next webinar here. Thank you everyone, and take care. Bye.